Hello, everybody, and welcome to Sparing Partners. Um, Today, we're talking about one of the really, I think, big changes in networks. So networks are becoming more complex, and we all know that. But what does that mean for testing? And the first time I did a project on testing, I thought, oh my God, this is going to be so boring. Just making sure that everything works. I couldn't be furthest away from the truth, from or my experience at least, because testing the network actually exposes all the complexity and the benefits, potential benefits of a network in a much better way. It helps you really understand the underlying technology in a way that just listening at what the network can do does to listen to what the problems might be and how to solve it. I think it's very interesting, but also very how can I say uh, very stimulating. And right now, there is a lot of things that are changing. So the way we tested the network during with 3G, 2G, 3G, and 4G have changed dramatically, just as much as everything else. So today, I have the pleasure to talk to Irina Cotanis, uh, whom I have known for a very long time, and we worked together when she was at Infovista, and she is now an independent technical consultant. And we're going to talk about the changes in how testing works in the current networks. So there's more complexity. The networks can do more. How can we make sure that they do more? But specifically, the networks are much more focused on the user experience. So we understand that having a good network doesn't mean to have a network that works well at the cell level, which is obviously necessary, but you need to keep your users happy. And how do you know that? So the testing has shifted more and more towards the user experience. And so with Irina today, we're going to talk about how is that happening? What does it mean? What is that we need to do differently, that we have started to do differently, and that we will need to do even more differently as we move forward with 5G and then eventually 6G. So Irina, welcome to Sparing Partners.
Hi, thank you so much for introducing me, Monica. Nice to see you. So thank you for your introduction. I have been working into wireless industry for many, many years, and especially my focus was testing the networks and the user experience. Actually, starting the user experience with even with the voice, when voice started with the standardization of voice quality algorithms and all the way. I worked in academia, so I was used to teach. So my focus is also on what is ahead, what are the challenges for the operators, which have been my customers for 27 years, because it's about testing the network. And it's very interesting. I could say that in the last few years, things are very dynamically changing. And of course, the networks are also changing quite a bit. And the very important thing that I think related to the user is the fact that networks, 5G and obviously 6G, 5G being the first G that is focused on the user. We talk about context-aware QoE. So you would expect the network will do the best, and you might not need the testing of the network. Well, the story is not like this. I mean, for now, at least, maybe in the future, in the next 10 years, 15 years, on our network on autopilot, that would be a different thing. But until then, we still need to test the network for the user experience. However, things literally need to change drastically, because we don't have anymore the voice and you just measure the most quality or the drop call rate and the block call rate. You are dealing with more complex services, a variety of services, and you need to do it faster, more cost efficient, in a more organized way. So all these things are changing the concept of how you test it. Now, let's first think about what we are testing. It's about when we say user experience. Now, with 5G, already with 4G, actually, you don't have anymore only humans. You also have machines. So we will, the testing of the QoE will, of the user experience, and by user, I mean humans or machines, will be very much dependent on the context, the service, that the application type on which you are doing the testing. And then you work on the dimensions of the user experience. If it's human consuming the service, all the services that you have on enhanced mobile broadband, you will have them like the video streaming and interactive gaming and so on and so forth. So you have all these dimensions that we are very much used to it, like the MOS scoring of the integrity of the service, or new things like interactivity. When you talk about gaming, it's a new dimension of it. But when it's about machines, it's something different. It's still the experience of the machine, and its experience actually impacts the outcome, the quality of the service that the machine can provide to you. So, right, in some cases we talk about the latency. In some cases we talk about the throughput. So it'll be very much dependent on the machine context, that if it's in the domain of health, in the domain of agriculture, so there will be other things that will be quality indicator, not necessarily QoE name. So that's one part, that it's a new paradigm when it's about the user experience. Now,
May I say
yeah.
something here? I mean, because again, so there is human and non-human, but when you go to the non-human, also there is, as you start saying, there is so much variety because there's different verticals, different services, different data streams. So there would be like something that it's a camera, something that is just a temperature sensor. So how do we put it all together? Because so you're an operator. What do? You need to collect KPIs for each type of machine. I mean, how do you think about it?
Well, I think that we'll evolve more and more towards having kind of flags. So you know that the requirements for a specific vertical or a specific slice of your, and now we move to network slicing, right? Will require specific KPIs. And basically, we look at three main ones that we are looking. It's about the throughput, the packet loss, and the latency. Now, with accent on one or the others, depending on the service that we are talking about. But you will have, from the operator point of view, you will have like quality thresholds. What is the real flag that concerns me? And or ranges. Maybe I will go for ranges, because operators will really need to optimize the delivery of their of the services, right? They will need to satisfy a lot of subscribers, as many as possible, to a good enough quality. And this good enough quality will depend from the service to service and from the application to application. So coming to your question, how we deal with it, I believe that the move will be towards kind of checking, like a thermometer, checking where am I with the quality indicators for a specific service. That's why tool vendors became, and actually it's something that started a few years back into standardization, and I refer to the ITU study group that it's focused on performance and QoS and QoE. measurements. It's about a more pragmatic testing. Instead of using each or every single service, which is almost impossible, you have kind of category of services defined by specific traffic patterns. And you can test these traffic patterns and provide quality indicators from this for this, and then you provide this in your tools. Operators can figure out, oh, okay, if my traffic is this kind falls in this category, this is the range in which I can work to can work while providing a good enough quality. Now, the reason that we have to move to pragmatic is not only because of the variety and diversity and all the verticals. Actually, even the slicing, the dynamic slicing of the network, it's also based on kind of the same principle. So when the operators are buying the networks, for example, from Ericsson, who is quite good in doing this dynamic allocation of the slices, they are already buying this concept. So the network itself is taking care of to provide a specific quality for the services that are consuming that slice, or using that slice, better to say. But the tool vendors will be kind of an additional testing of this. This really works. And the reason is that everything is based on AI ML. These are proprietary algorithms, and it doesn't mean that they are doing the same and they are the same. It's how you define them, what is their performance, and so on and so forth. That's why you always have to double check if you as operators who are responsible for the network, you are really doing this. But so it's not about only, coming back to the topic, it's not only about the pragmatic thinking. It's not only about the variety and diversity. It's also about the fact that services are smarter and smarter. Service providers or application providers are smarter and smarter. They themselves, and a very, very good example is video content delivery provider, like Netflix or YouTube. These guys know very well their job. They have their proprietary solutions for identifying the quality, and based on ML and I, they can sense the quality of the link they are communicating to, the device that is consuming their, by device I mean the performance of the device, as well as the display, the quality of the display, and it doesn't make sense to provide high resolution to somewhere that somebody consumes on a low end device, the video stream. So they become very, very good in doing this. So you won't expect that the quality is going bad, so operators have to be concerned. That's why they don't need so much sophistication in doing this kind of testing, but rather this pragmatic way of testing. And the other thing is that, well, yes, they are providing these very high quality services, and they are also fully encrypted. So for tool vendors, it will be very difficult to test the bit stream itself. It will be more high level with pragmatic solutions that will shape based on traffic patterns to provide a quality indicator.
And I guess that the issue also is that you need to be able to provide different services at the same time. So, you know, like back to 2G, it was just voice capacity, that was it. Now a network has to provide voice, data, video streaming, video downloads. So all sorts of things at the same time. So each service, so the operator or the cell site is going to be able to support all of those services. But the question is, how do they all coexist in an optimum way? So Netflix can be optimizing for video, but then the operator has to put all of it together so that everybody's happy with different types of priorities for different services. So at what point you run into a situation where the basic testing tells you, yes, you can do it, but then how do you actually perform in real terms? So what's the difference between testing and then monitoring? And I get a sense that the two are becoming kind of one and the only. It's like a continuous testing in a way because the network continuously changes, the demands continuously change. So where do you draw the line, or is there a line to draw?
Well, with the incoming networks, the networks that are already here, actually, the 5G and 5G advanced even with release 17, 18, they already, the networks, the 3GPP defined already QoE measurements. So the network itself measures, and also it's an enhanced communication between the device, not only enhanced, it's a more intelligent communication between the network and the device. They are reporting each other, so they know, they are more aware of themselves. Therefore, you would think, okay, because of this, I just need to monitor and to look for these QoE measurements that the network provides. Obviously, the network reacts. So if the QoE measurements go below a certain threshold, the network reacts or the device reacts. It's generally the network reacts to change things for that particular device. But therefore, I think that better to say it's kind of continuous monitoring with not all the KPIs in the world, because this is another thing that people are doing. I need all the KPIs. I need all the measurements. It's not necessarily, because a lot of them are overlapping. It's kind of, you don't get more information. It's redundant. You have to focus on metrics that you know for sure are affecting your user experience, machine or human, doesn't matter. So you are focused on those, and maybe a smaller set that you know are directly impacting, so you can follow them. So I think that this is the future monitor. When the flag started to be red, then you start to be concerned and you go there and you do the measurements. And to be honest with you, this is something that you can also call AI-driven testing. And I am thinking now about mainly based on AI-driven, based on crowdsourcing or drive testing even. But if it's AI-based, I come back immediately. If it's AI-based, it's kind of, you do it when, where, and when and where, or for what is needed. You don't do it continuously. You monitor, you have red flags, you go on this AI-driven measurement campaign. Now, when I say AI-driven, what do I mean? I mean the fact that these campaigns are triggered from outside sources, coming from the network, coming from operators that already you have engineers and they know, and then you launch this. That's one way of doing it. The other way is that you can decide, for example, testing, you can decide, okay, I am deploying, or imagine you have a private network. So you deliver a private network to a party, right? And you know that you want to test all the things that these guys are concerned of. Then it's a focus, it's a campaign focus, and you are deciding on the measurements there. But even in this case, then the measurement probe that you have can be smart enough. It can sense the networks, and they will then trigger specific tests when the network seems to degrade from whatever reason. You can test specific when the traffic load, so you change the traffic load and it senses and starts the testing because they know, oh, well, I might get into problems. This kind of AI, this is what I mean by AI driven. So to answer to your question, yes, I believe that generally we are talking about monitoring. Monitoring should not be based on a pile of KPIs because it's useless and a lot of money with no sense spent. And you go for testing, how should I say it? the AI driven, let's say, but it's kind of a directed testing that can come from outside sources like performance management, configuration management. So this kind of triggering this, as well as from operators having their department of monitoring specific areas and having concerns when the flags are red.
Yeah, and I think that this is really important because a lot of people think that because an AI model can get any amount of data, any amount of inputs, then just throw everything there and do everything just because you can. But yeah, you can, but you're going to become much less efficient. So a model, an AI model that is smaller, if it works, is so much better because not only uses less resources, but it's actually less, there's less noise. So avoiding irrelevant information is, and it's hard, it's not trivial, but it's actually really a key to get the thing working and do it what you want. So I think it's quite important. And so, but at the same time, so you get the KPIs, but you don't need to have them just at the network level. You need to have them at or at a cell site level for the different devices, human, not human, and for different services, right? And then try to understand how everything relates and then optimize based on that. Is that?
Yeah, exactly. So it's kind of, okay, you don't have all the, because all the, especially a lot of RF KPIs are indicating towards an upper layer KPI, right, at the upper layers. And actually, even the effect it's at the application layer. So that's I was saying you look at the application level of specific KPIs, and then you use a smaller set that reflects underneath what's going. Now, it's very useful to have this because operators can identify immediately if it's their own fault or it's the service application fault, because it can happen, right?
Yeah.
You especially, for example, the good example is the video streaming. They rely on content caches deployed in various things, so age processing as well. But what if some of these fail? So if this fail, the service will have poor quality, but it's not because of my network. I provided you everything you needed, but you couldn't because of your service. So that will be also an important indicator for operator. Unfortunately, bottom line, he is always at fault. So when you use and video streaming, you are frustrated because of the net, but because of the operator, not about Netflix. So they are still responsible, but they will know how to approach this in this kind of things. So they will know that it's something really going badly with the service itself. It's not about the network, and that's why
Yeah.
this kind of set of KPIs help them.
Yeah. I mean, and then, yeah, I mean, I guess I'm sure the subscriber will always call the operator first, regardless, because they don't know who's the cause is, but at least the operator can say, well, we can't do anything because, so, I mean, you know, so that's, that's quite important. Now, you said a lot of very important things, but so how does it translate into, well, what is it operators are doing? Because initially they say, well, we're not gone farther enough. So what do you see the progress being? So we have more and more 5G. Are operators following through with testing and monitoring, or they lagging behind? And how do you see changing in the next few years? And eventually with 5G, 6G.
So theoretically, be 5G advanced especially, and obviously 6G will come with the, as I mentioned, the context-aware QoE. Meaning that it's user-centric, it's adaptive services that will enhance QoE through traffic shaping, content caching, through age computing processing where you have the AI and MLs. So to a large extent, I think that testing will be less necessarily because you can just monitor it. However, this is it's on paper. I mean, ideally you will be like this, but the secret is that all the pieces I mentioned, a lot of them are proprietary solutions. So operator buy from Ericsson or whoever a solution that has all this embedded. You already, with 6G, we will already talk about native AI networks. So basically every single element in the network has an AI algorithm that helps it to optimize this concept that SON, or self-healing, prediction of faults, all these things are already there. So you would expect that everything should be fine. But testing will exist in a much smaller scale, definitely, because you will have a differentiator of the quality of all these algorithms that are running in the network. So the performance, each of these algorithms have different performances. You mentioned before the training and the data size and so on and so forth. Yes, because you have different scenarios. Your algorithm has been trained on a set of scenarios or a data set. You can't do for everything in the world. So that's why these differentiators really would call still for doing the testing in a smaller scale, more pragmatic scale, as I mentioned before. And to underline one very important thing that maybe I am talking way ahead at times, my karma in my entire profession was that I was talking about things way ahead of my time. So, but I have to say it. I really have to say it. I said it internally when I used to work with InfoVista and all the companies. This is going to happen. So people are talking about generative AI, right? Everybody thinks it's happening, we'll have it in the networks and so on and so forth. The reality is that the networks themselves are completely different than any type of data sources that people developed already AI. Networks are different. For the AI, as you mentioned, for the AI to take the inputs, all these inputs need to be something that the algorithm understands. How I'm transforming these inputs for an AI to understand? And how are these normalized across an operator that uses Ericsson and Huawei equipment? You have to have the open interfaces. Well, the open interfaces requires a specific business model between the parties and so on and so forth. So I don't want to go into all these details because it's another story. But anyhow, the point is that I just noticed that it's a publication late December or November last year, where it's a quite long document, research institutes, operators, network vendors have been involved in this, in what are the algorithms that are suitable for the network. What are these generic AI that the networks need, and what are the requirements for them? So for now, to be honest with you, for a long time, it will be like we are using AI, ML, like on top of the network with tools, smarter tools and smarter monitoring, but this is not the way that will happen in the next 10 years, 15 years from now on, because things need to change and to adapt.
Yes, and you're right, and I think there is a lot of work to do. But then there is also the sort of parallel issue that you mentioned. Right now, a lot of those testing is done um, by the vendor, but that's because it's a vertically integrated network. Now, as the network become more open, how do we deal with that? With the openness, so that the Ericsson solution might be very good, but then if you have multiple vendors, it might not work because the other vendor at the other end uses a data format that is different, and so the AI model can't work, even if you have an excellent model. So how do we deal with the, as I said, we need to have more data, I guess, data standardization, but is it coming?
It's I think that because of ORAN, I think that ORAN was the trigger for how to define the open interfaces. Because this is, I really need to hook up to Ericsson and Huawei and have something common. I think the evolution of ORAN really helps into this direction. Because even if it's an ORAN, again, you have the RIC, the radio intelligent controller, right? It's supposed to have ML, MI in there quite a bit for all the use cases that covers. But it's multi-vendor. How in the world are you going to do it? Unless your multi-vendor is still the huge Ericsson or Huawei, because they provide ORAN as well. So it defeats the purpose that operators wanted the ORAN, right? They wanted multi-vendor rather than the huge giants. So I think, coming to your question, I think the ORAN was the trigger of literally vendors understanding that they really have to open the interface and be able to communicate. And standardization, this is the way the standardization goes. They try to define all these open interfaces, even looking even especially for ML AI. It's a working group under ITU. It's study group 13 that it's taking care of this. They define quite, and you have a lot of its operators, vendors involved. How you define these interfaces? What should be this? The algorithms will be proprietary, but what are the outputs, the inputs and outputs to your algorithm? They have to be the same. Otherwise, how they will work together? But yeah, maybe 3 years ago, I would have thought that things can, because of all these changes, things go very, very slow, will go slow. To my honest surprise is that things are moving faster. Somehow things are moving faster. It might be that it's helped a lot by the AI ML developments that talking to people from other industries, they recognize, oh, well, it's faster than we thought. You have all this competition between the companies involved into this and the business opportunities. Maybe that's why. On the other hand, it seems to be fast, but we will see how good they will be. So we don't know. It's very promising. It seems it's you'll have we all as subscribers will be the happiest persons in the world, and the VPNs, right? The private networks owners, they will be so happy that the enterprises, they will be so happy about the network. But to be honest with you, I kind of doubt it's kind of a decade in front of us, at least, I would say.
Yeah, I guess that, yeah, you see a lot of interest, a lot of efforts, but we still have to see how is that going to pan out. And, if you look at any other technological change, there's always a challenge at the beginning. It's never easy.
Yeah.
And that's just in the nature of things. And otherwise, we'll be bored.
Yeah. And there is also a very important thing that I forgot to mention when I was talking about testing. When we're talking about testing, I think we should not forget that we are talking about two different categories of testing that make a huge difference. One is I call it device-based. UEs, either if it's a drive testing or crowdsourcing, it doesn't matter. The information coming from those pieces, it's with very, very high resolution. So basically, you know exactly what's happening every single moment, and in a very accurate geolocation position, which is something. The other part is, and you have a lot of tool vendors, there are huge companies working into cold or not called, let's say user traces testing. These guys know exactly where, what is the flow, where it's going, the hip hops through the network and things like that. Up to the device, they will know the device as well. But they won't be in the device. They will be on the trace of the device. These data sets have much coarser resolution. So this is something that why? Because it will be way too much to store all this information. So generally it's like 15 minutes, and it's not geolocation. It's geolocated based on the base station. So around this area you have this. Now, the real user experience is basically how you can correlate this
Yeah.
with this, right?
Yeah, because otherwise you have to know that somebody gets a bad
Yeah,
experience, doesn't do you
yeah.
any good unless you know where it's coming from, the bad
But
experience.
But here comes into the picture that I mentioned before. It's mainly monitoring. I can monitor the traces. I figure out what is the ranges of the quality, and then problem flagged from whatever source or intervention, I rely on crowdsourcing that I have already in place, or dive testing campaigns and things like that, you know.
Yeah.
But
Yeah.
yeah, and it's dealing with the resolution of the data, the transformation of the data, how you store this data, a lot. And to be honest with you, in again, from my ITU experience, operators from different parts of the world are very concerned of how in the world should we do it? Because I have all this data. Is it right to do this? Is it right to do that? And being constrained of the costs. So it's very interesting to see that you have a lot of input. It's not coming only from vendors, network vendors, but also from the operators concerned of the problem. How in the world are we going to fix this? And not for
And there's
themselves, but for the entire, for the industry itself, you know?
Yeah, and I guess, as you point out, is sort of a trade-off because there is cost and effort, and at some point you don't want to be spending all your, resources, efforts, and money on
Mhm.
testing, but you
Yeah.
don't want to spend that. So you need to find out what is a good space, a good spot for you to be.
Mhm.
To
Yeah.
it's like, you want to optimize the network, but you don't want to go so far out that you spend all your
Yeah.
time and money to optimize the network. So anyway, our time is up, but I think we should talk more about what's going to happen with 6G next, because we haven't covered that. But that's obviously, but I guess there's a lot to do within 5G
Yeah.
before we get to
Yeah.
to 6G, right?
Yeah, that's very true. It's a very good point that you are making. So if you ask me, for now, let's fix 5G and let's exploit it at maximum, and then talk about 6G. Before coming to the podcast, I double checked the timeline on the 3GPP developments, and the requirements are, they will start to define requirements with release 19, 6G requirements, but this is this year towards next year. And only that after that you will have the use cases, the studies, and only after 2030 we'll talk about something, specifications and so on and so forth. So it's far away. Let's fix first the 5G, because Monica, let's not forget, people were so excited. I want to have the 5G. We should have the 5G. And you have operators having your 5GE. You remember you have on your device 5GE, which basically is LTE advanced, but they didn't want to say it. It's called 5G evolved, right? No, it's actually LTE. Why? Because LTE itself was so good, is so performant, so reliable, that you don't see a huge difference in quality when it's about, from the user perception point of view, between the LTE Advanced that uses all the nice features related to LTE versus the 5G. right? So it's kind of, do my subscribers pay for the difference to have the 5G? I have to decently price this in order to make sure that I have the subscribers. So let's optimize this thing. Let's make this work as good as it gets, and then we'll talk about 6G. But for a podcast talking about 6G, it's very interesting. There are very nice aspects related to 6G, because for me, monitoring what's happening right now, it's kind of 6G is no more about what we are used with the concepts of 5G. We talk about the integrated sensing and communication. You have these sensors or the network, and the combination of these that will be your new mobile network, not literally the what in the sense, but that's for another for another.
For the next one.
Yeah.
Well, thanks, Irina. Thank you so much for sharing your insight. It was incredibly interesting and refreshing to hear all of this. Thank you so much.
Thank you so much. Thanks to everybody for attending. Okay, bye now. Bye now, Monica.
Thank you all for listening in, and continue to listen to us on your favorite podcast platform. Thank you.